We're reviewing for final exam for Math 161, and this topic is on inverse functions. Given f of x equals square root of x plus 5, let's start by graphing this f of x. So I'm going to make an xy axis, x-axis and y-axis. And let's look at that function. F of x equals square root of x plus 5. Well, square root function starts at origin, like 0, 0, but this function has a piece of transformation. Look at that. We have plus 5 inside the square root. So how will that adding 5 inside square root move the graph, okay? This will be the horizontal translation, right? So we will have to shift the graph left 5 units to plot our first point. So instead of at the origin, we're going to have to go to the 5 to the left and plot the point. So you know what? I'm going to move that y-axis a little bit to the right. So I'm going to go 5 to the left. 1, 2, 3, 4, 5. And look, there's no number being added outside, right? So there's no vertical translation. We're not moving up or we're not moving down at all. So just plot the point on the x-axis at -5. So that's where the square root function will start. Now to graph a function, it's always nice to have a couple points, right? So I'm going to find maybe like 2 more points to plot the square root function, okay? So we do know this graph will start at -5, 0. If you plug in -5 into this function, you're going to get 0. Now I'm going to plug in another number. What will happen if I plug in -4? Now let me check, okay? So if I do square root of -4 plus 5, that is square root of 1, right? And we know that's equal to 1. So look, when we plug in -4 into this function, we get 1 out. So I will plot my second point at -4, 1. So go 4 to the left, up 1, and plot that point. All right, I'm going to find one more point. But look, not every numbers will work out pretty under square root. We want to make whatever is under square root, the radicand, a perfect square. So what will happen if I plug in, I'm thinking, you guys, I think I want to plug in, what are they thinking here? -1. Now see this, okay? See if this, because you know, you could have plugged in -3 and -2. It will just give you a really ugly decimal that we really rather not plot. So look, see what happened if I plug in -1 into the square root, okay? I will get square root of -1 plus 5. You see where I was going with this, right? Because if you do -1 plus 5, you get 4. And 4 is a perfect square, which you can simplify to 2. So if I plug in -1, I will get 2, which means I can go 1 to the left, up 2, and plot the point. So that, well, 3 is enough, but, you know, just so that, it's kind of fun to think about what number will give us a perfect square. What will be your next choice, okay? Which number, if you plug in here, will give us a nice number? I think I'm going to go with 3 next, okay? Look, what will happen if I plug in 3 into the square root function? We will get square root of 3 plus 5, which is 9, square root of 9, and that simplifies to 3. So I know if I go 3 to the right, the graph will be up at 3. And guys, that's enough. I think I got too many points here, okay? I'm going to connect these dots and have a square root function, okay? That looks like this. I think actually they are asking us for the info, the domain and range in part B. Well, they didn't. Now, I am going to find the domain and range of this function. Why? Because I noticed that this is about inverse function. Okay, so domain and range will help us to find the domain and range for the inverse function later. So I'm just going to go ahead and find it right now, okay? So let's talk about the graph here. Domain of this square root function. Notice it starts at -5 on the x-axis, right? We're going to say bracket -5, comma, positive infinity. So it starts at -5, but it goes forever to the right. That's the domain of this function, okay? Now, what about the range of this function? How low does it go? Well, the lowest point of this graph is 0. It doesn't go below 0, right? It doesn't go into the negatives. It has an x value of -5, but I'm talking about how high and low. It doesn't go below the x-axis. So we're going to say that it starts from 0, but notice it goes up forever, right? So the range is from bracket 0 to positive infinity. Now, that's it for part A. But I'm going to continue and write the equation for, okay, I'm moving on to part B now. Let's do the inverse, okay? So, for part B, gotta be a little careful here because the function they gave us is a square root function, okay? We're going to write the equation for f inverse of x. Now, how do we do that? You first write f of x as y, but keep everything the same for right now. After that, switch x and y. Instead of y equals, say x equals. Instead of square root of x plus 5, inside that square root, put y plus 5. So you interchange x and y, okay? Now, let's solve for y. To get rid of square rooting, I am going to square both sides, okay? So if I square both sides, I'm going to get x squared. And look what happens. If I square the right-hand side, the square root and the exponent of 2, they will just cancel out. So what comes right out? Y plus 5 comes right out. Now we're one step away. If I want to solve for y by itself, I will subtract 5, remove that adding 5 to the other side. Okay, so what will happen if I move this or subtract it? I'm going to get x squared minus 5 equals y. And we are done. Once you solve for y, you are done. Now let's write the answer for part B. F inverse of x is equal to x squared minus 5. But we're going to have to be careful. That's the equation for f inverse of x. But this is a quadratic function. And you remember, regular quadratic functions, domain is always all real. But this isn't any quadratic function. This has to be the inverse of the square root function. So look, the next part, well, they're really asking for it in the very last section right here. So they are asking for us to write the domain of f inverse in interval notation. Now, it will be wrong if you say all real numbers, okay? Now, that's correct if you're talking about any quadratic function, but this isn't any quadratic function. This is the inverse of a square root function. So watch how I use what we found over here, okay? Remember, when you write inverse functions, you switch x and y, right? Now, what do we call possible x values? Domain, right? And y's are ranges. So when you switch x and y, you end up really switching domain and range. So look at this, okay? The new domain, the domain for f inverse is going to be what used to be the range of the original function, which is from 0 to positive infinity. Now, they've never asked me, but if they ask me for the range of, f inverse, what will that be? That will be the domain, what used to be the domain of the original function. So, when I grade the final exam for Math 161, for this particular problem, there's a very common mistake of students saying that the domain of a quadratic function is always all real. I love that, but if you're looking at an inverse of a square root function, you have to be extra careful. Instead of saying positive infinity to negative infinity for the domain, you want to say that the domain should be the same as the inverse of the original function. So this one was a whole pager. Took me about 10 minutes to go over. But this one is actually a 3-part problem. So yeah, and that's it.